video contents are visible through the traffic signs, through icons in the traffic signs. So, we'll show in a demo of it. It's a Java program that takes long to be loaded. So here we are not showing the way we are navigating, but in the previous video we showed the tangible object with which we drive the car. So basically we drive the car with a tangible object, and then whenever we are in front of a given learning object, here we are searching for Java, then a video is appearing. And when we cross the traffic sign of the learning object, the metadata here are changing depending on the object itself. So basically we can see the metadata of the learning object and then decide if we want to double click it or not. So interacting with this game interface can happen through gestures, keyboard, or the tangible interface. And so before we there are different other types of tangible interfaces used for learning, and particularly for children with disability, is the so-called so-called memory game. So tangible object for memory games where people will be hitting on pressure sensors. So this way the user has a direct tactile feedback on which tactile he pressed, and the tactile feedback varies depending on the object behind it. So that in the memory you don't only have memory of the visual memory, but also the tactile memory. Similarly, learning physics with tangible objects becomes more interesting when we can feel the physical objects themselves. Like here in this case, Jongin is feeling the electrical charge. So he has a positive element, and the positive element cannot be coming to the positive element. However, positive and negative, he cannot put it into the positive element, as in this case. However, the negative element absorbs the positive element right away. So it's whether it's electrical engineering or electrical field or magnetical field, the same theory is applying there. So same thing, orbital simulation with tangible object. So basically you try to let an object go around the given orbits. hit each other, they are exploding, and then you feel the explosion. Not only learn physically about the poly, but they can feel it, and when they change the number of polys to 2 or 3, then they feel that the force that need to apply is reduced by 2 or 3, depending on the polys and the mass. So, as we have seen, there are many ways of using tangible learning objects and VR metaphor in e-learning. Now, we've done a couple of usability studies with many users. For instance, the adaptation modules that I showed you, we tested with about 35 students at the undergrad level, aged between 21 and 27, and many of them, in fact 17 found it very advantageous to use the same learning object in different contexts, so that their interest or their concentration is not on learning new visual artifacts and how they are correlated to the content, but rather the physical aspects, or in this case, the networking aspects that we wanted to teach them. In the case of the toddlers tangible object, we tested with, as I said, with the 12 toddlers aged 4 to 15. And the results were very promising. The issue is that the teacher, or in this case, in the toddler kindergarten, they advise to have to make the toys that the children are using as tangible object, so that when what they wanted is they wanted the children to learn that a chicken is afraid of a snake. So basically, the intelligence is put in the tangible object. So when the child